Okay, so we just learned how to do Lewis structures. In this one, what I'm going to do is I'm going to do a few Lewis structures with you. So first Lewis structure we're going to do is CO2. Now, what I would recommend is you pause the video, go through the steps, do CO2. Okay? So hopefully you have paused the video and have worked on that CO2, and now you can see how I do it. So what I'm going to do, first thing, I'm going to count the electrons. 4 electrons for carbon. We have 2 oxygens, each with 6 electrons. And if I do my math correctly, that brings me to 16 electrons. And 12 plus 4 is 16. Now I'm going to put down my central atom. My central atom in this case is carbon. Why? Because, like I said, carbon likes to be in the middle. Now a bond to each terminal atom. Well, I don't know why I'm making this so big. Doesn't matter. There we go. Now how many electrons do I have remaining? Well, I just used 4 of my 16, so I have 12 electrons remaining. Okay. So now all I have to do is recognize that I just put those down as pairs on my terminal atoms. 2, 4, 6, 8, 10, 12. Okay, we're good, right? Right? Well, let's find out. Oxygen has a full octet. It's good. Carbon, however, does not. Carbon, it's sad. It has only 4 electrons, so it needs a full octet. So here's what we're going to do. I'm going to just redraw it just so I don't change what I've already written. And I'm going to show you what I do. So I'm going to redraw what we already did up there. Now step 5 says, if we don't have a full octet, we share electrons to make a double bond. So I'm going to choose a pair of electrons. Doesn't matter which electrons I choose, and I'm going to make a double bond. So I'm going to just pick this one, and I'm going to put it right there and make a double bond. Boom. Okay. And now those electrons just go away. Does carbon have a full octet now? No, carbon only has 2, 4, 6 electrons. So I'm going to do that again. I'm going to take those electrons, make a double bond. Again, doesn't matter which one I choose. And now carbon has a full octet. So we see that here. Carbon finally has a full octet. And did we change the octets on the oxygens? No, because those electrons came from the oxygen. They're still bonded to the oxygen. So everything is good. So that is the correct structure for carbon dioxide. Now let me do 1 or 2 more very quickly. So again, I would recommend that when I do these, you pause and try and do them yourself. Okay. So let's do SO2. This one's a little bit tricky. SO2. Go ahead and pause it and try it for yourself. Okay, I assume you've paused it and you've tried to do it yourself. Now let's do it together. Oh, what didn't I do? I didn't start with adding up the electrons. So sulfur is below oxygen, so we have 6 electrons plus 2 times 6, 6 electrons. That gives me a total of 18 electrons. So put down sulfur, oops. I put down sulfur as my central atom because it is less electronegative than oxygen. You can look that up if you don't, if you want to. Bond, bond. Okay. Now that's 4 electrons. That leaves me with 14 electrons. So now I put those around. 2, 4, 6, 8, 10, 12. Okay, I've used 12 on the terminal atoms. Where do I put the other 2? There you go, on the sulfur. But does everything have a full octet? No, sulfur does not have a full octet, so what am I going to do? Again, I'm going to take a pair of electrons, and again, I don't have to do this in a different color, I'm just showing you, and I'm going to just take 2 electrons off of there. Okay, it may be easier for you to draw a completely different structure just so it's not messy, but there we go, there's SO2. Okay, and now let's do one more. You'll find it's fairly similar, but there's one key difference here. So NO3 minus, nitrate ion. The key difference here, let me explain this before you give it a shot, is we have that charge, obviously, okay? And that charge is important. We have to take that into account. So when we do the Lewis structure, we have 5 electrons for nitrogen. We have 3 oxygens, each with 6 electrons. And then we have 1 electron extra. And that 1 extra electron comes from the charge. If this was a plus charge, like an NH4 plus, we would simply remove 1 electron. Okay, so let's go through. Now, from there, you guys can finish it, I'm sure. So go ahead and give it a shot now. Pause the video and work on it. Okay, so now that you're back, let's go ahead and do the Lewis structure. We have nitrogen in the middle. It's the least electronegative. Oh, I never added these up. So that is 24 electrons. Nitrogen, oxygen, 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 and does it matter where I put them? Some people always want to know, why do you put them where you put them? It's just arbitrary, okay? So 2, 4, 6 electrons used. That leaves me with 18 electrons total to distribute. 2, 4, 6, 8, 10, 12, 14, 16, and 18. Of course, what do we notice? We notice that nitrogen does not have a full octet. So I'm going to take an electron from anywhere I want. I'm sorry, a pair of electrons from anywhere. It doesn't matter which oxygen. We'll talk more about that later. And make that double bond. Now nitrogen has 2, 4, 6, 8 electrons. All the oxygens have a full octet, so this is good, except if we were to count this up, it has 24 electrons, which is what we're supposed to have, by the way. But 1 nitrogen and 3 oxygens should only have 23 oxygens. So we need to go ahead and indicate that, yes, indeed, this is a charged species. This is a polyatomic ion. So we do that by putting brackets around it and then the negative charge outside the brackets. And again, if it's a positive, put a positive. If it's a 2 negative, we put a 2 negative, whatever it is. All right, that's enough for now.